Hi people, this session is on dividing polynomial, or what we call performing long division in polynomial. So just a recap, in your primary school when we perform long division for numbers, okay, we, like for example this case as shown in the notes here, is 44 divided by 3, by 44 is the dividends, 3 is the divisor, then after you perform long division, 14 is the quotient, remainder is the 2. So key thing for this part in long division in polynomial is this concept here, okay, which later on this concept of dividends equals to divisor times quotient plus remainder, it will be used in the subsequent topic on remainder and factor theorem, and this is called the division algorithm for positive integer. So this portion about the long division, we can use it for making improper fraction to proper fraction, which will be made use of in the partial fraction, which is the last topic of this chapter, which later there'll be one examples and we'll recap this again. Okay, how this proper improper comes about. For example, just now we have this 44 equals to 3 times 14 plus 2. If I divide both sides by 3, I'll have 44 over 3 equals to 3 times 14 plus 2 over 3. Then my right hand side is simplified a bit. So I have this 3 times 14 over 3 plus 2 over 3. Then here I cancel, so I get 14 plus 2 thirds. So that is about this. Okay, so let's take a look how long division can be done for algebraic fractions. So let's take a look. So over here I have 2x squared minus 13x plus 21 divided by x minus 3, whereby this is dividends, this is the divisor. Okay, do take note, if you recall, in our long division for numbers, our job is to slowly remove term by term. Same thing for algebraic fractions. So for this part A, our job now is to remove 2x squared first. If 2x squared is not being removed, we cannot proceed to remove subsequent algebra terms. So take note, there's a minus sign, remember to put, then with the bracket. So 2x squared, if I want to remove 2x squared, I must have another 2x squared to remove it off. So ask yourself this question: what times x give you 2x squared? So it'll be 2x. So 2x have the habit to write above the x term for the dividends. So 2x times x, I have 2x squared. Then we should have 2x times minus 3, so I have negative 6x. Okay, so if this 2x squared minus 2x squared is 0, negative 13x minus negative 6x will become negative 13x plus 6x. I'll have negative 7x. Then at this stage, student will be asking, do I need to continue with the long division, or do I stop here? Take note, imagine if when we are performing long division for numbers, for example just now 44 divided by 3, I think, is it 44 divided by 3? Yes. So I have a 1 here, I have a 3 here, so I have a 1 and 14. So 14 is more than 3. 14 is more than 3, which is 14 is more than the divisor, so we have to continue. So for algebra expression, how do you know we stop? When the degree of the current expression is smaller than the divisor, then we will stop. Like for example here, now the current degree of this negative 7x plus 21, the degree is 1, but the divisor degree x minus 3 is also 1. So when the degree are the same, we have to continue. The remainder degree must be less than divisor, then we can stop. So over here, I have a minus here. Okay, subtraction. So negative 7x plus 7x then you'll be gone. So here must be a negative. So here will be a negative 7 to give me negative 7 times x will be negative 7x. So negative 7x plus negative 7x minus negative 7x. I'll have negative 7x plus 7x, so gone. Then negative 7 times negative 3, I have positive 21. So now remainder equals to 0. So in this case, our quotient is equals to 2x minus 7. Remainder equals to 0. Okay, that's how we perform long division for algebraic expression. Let's see a few more. Okay, here 14x squared minus 2x minus 368 divide by x minus 5. So same thing, here's a minus. Okay, subtraction. So I have to remove 14x squared. What times x minus 5 give me 14x squared? So it'll be 14x. So I write above the x term in the dividends. So 14x times x minus 5, I'll have 14x squared minus 70x. So it is 14x minus 14x. So 14x squared minus 14x squared gone. Negative 2x minus negative 70x. So I have a 68x minus 368. So this 68x minus 368 degree is 1. Our x minus 5 degree also 1. Same degree, so we have to proceed with the division. So now I have to remove the 68x. So I have to 68 minus 68x, is gone. So here plus 68. So 68 times x minus 5, I'll have 68x minus 340. So I'll have negative 28. So now this is negative 28, which is degree 0. Then our divisor degree is 1. So now it's lesser. So we can stop here. So that's an indication that this long division we can stop. So over here will be quotient equals to 14x plus 68. Remainder equals to negative 28. Okay, let's see two more before I let you all practice some questions. AC. So I have 3x cubed plus 4x minus 5, then x plus 1. So with this, I have to remove 3x cubed. So 3x cubed, what times x plus 1 give us 3x cubed? Well, I suppose it's 3x squared. Let's still mistaking. In the dividends, there's no 3x, there's no x squared term. So where do I write my 3x squared then? No problem, because after x cubed, in between x cubed and 3x cubed and 4x, it should be a x squared. So I write in between the above the plus sign lah. So I have a 3x squared. So 3x squared times x, I have a 3x cubed. Then 3x cubed times 1, I have a plus 3x squared. And for this, okay, 3x cubed minus 3x cubed gone. 4x minus 3x squared. I'll have, we have to write the highest power first. So negative 3x squared plus 4x. So this degree is 2. Our divisor degree is 1. So we continue because the remainder degree now is bigger. So to remove 3x squared, I need to have negative 3x squared. So I have a negative here, 3x. So negative 3x times x plus 1, I'll have negative 3x squared minus 3x. So it is negative 3x squared minus negative 3x squared. So minus becomes plus. So my x squared gone. So I have a 4x minus negative 3x. So it's equal to 4x plus 3x. So it's 7x. I have a minus 5. So this 7x minus 5 degree is 1, which is the same degree as the divisor, which is also 1. So in this case, we cannot stop because same degree cannot stop. It must be smaller. The remainder degree must be smaller than the degree of the divisor. then we can stop. So with this, I have a minus here, so I have a 7. Okay, so it'll be 7x plus 7. 7x minus 7x gone. Negative 5 minus 7 will be negative 12. So this one degree is 0, negative 12. So divisor degree is 1. So we can stop here. So it means that the quotient equals to 3x squared minus 3x plus 7. Remainder equals to negative 12. Okay, so I think by now most of you should have the hang of how long division is being done in polynomial. But nonetheless, let's try one more, last one. So I have a 3x cubed minus 7 divided by x minus 3. So I want to remove 3x cubed. Sorry, I want to remove a 3x cubed, so open bracket. So I should multiply with 3x squared. Same thing, so 3x squared, put it here. So 3x squared times x minus 3, I have 3x cubed minus 9x squared. Okay, so 0 minus negative 9x squared, I have positive 9x squared. Then bring down the negative 7. So now same thing, I cannot stop here because the degree of this is 2, whereby my divisor degree is only 1. So we have to proceed or continue with the long division. So with this, I want to remove 9x squared. So I must have a 9x squared underneath. So plus 9x. So I'll have 9x times x minus 3, I have 9x squared. 9x times negative 3, I have negative 27x. Over 27x minus 7. After that, I want to remove, same thing here, 27x minus 7, degree is 1. Divisor degree also 1. So we cannot stop here. So we have to proceed. Okay. So now I have a 27 on to minus here. So must have positive 27. Positive 27 times x minus 3, I have 27x minus 81. So 27x minus 27x gone. So negative 7 minus negative 81, I have 74. So with this, quotient equals to 3x squared plus 9x plus 27. Remainder equals to 74. So far, so good. So with this, let's take a look at a few more. One more long division which I can let you all try out. So for this, okay, I'll give you answer for part A. I'll do the part B. Remainder here per se is negative 29. The remainder, the quotient is the quotient will be equals to negative 2x squared minus 3x minus 1. Okay, then important is the part 2, which I've not shown you all yet, which I think you all should be able to, but I'll still show just the part 2. So this one you can DIY. Part 2, they say express, they say hence, take note hence. So we have to use our long division working. So we have to write into dividends equals to divisor times quotient plus remainder. So this is the dividends equals to, please make sure you have a bracket, dividends, sorry, divisor times, I don't use the times, I'll just put it beside, times the quotient and plus the remainder. So this will be for this. Okay, let's proceed to the next one. They say change this algebraic fraction as a proper algebraic fraction. Why this is improper? Because the numerator degree is equals to 3, denominator degree is equals to 2. Okay, just like maybe 4 over 3, this is also called improper fraction because the top number is the same as the top number 4 is bigger than the bottom number 3, so this is improper. But do take note, for algebraic fraction is a bit unique. For example, I have x plus 1 over 2x plus 1. This is improper. Why? Because this is degree 1. This is degree 1. When the degree are the same, for algebraic fraction is considered to be improper. So this one you have to be very mindful. So for this, how to make it into proper, we have to use long division. So I have my 6x cubed plus x squared plus 9. Long division. Divisor is x squared plus 5x minus 2. Take note, for students who read broadly, there's a long division method called synthetic division, which we usually don't teach in school. Reason is synthetic division have some disadvantage, whereby the divisor must be having degree 1. If the divisor is not degree 1, we cannot use synthetic. So that's why you can see now the divisor is degree 2, 3x squared plus 5x minus 2. Therefore, that's the reason why I never introduce synthetic division to everyone. But if you want to find out more, you can just go and search online. It's very easy. So over here, I want to remove 6x cubed. So I have a minus sign here. So 6x cubed. So what times 3x squared plus 5x minus 2 to give us 6x cubed? So it will be 2x. So 2x. So right here, 2x. So 2x times 3x squared, I have 6x cubed. 2x times 5x, I have positive 10x squared. Then 2x times negative 2, I have negative 4x. With this, I do the subtraction. Okay, 6x cubed minus 6x cubed gone. X squared minus 10x squared, I have negative 9x squared. Then minus 4x plus 9. So you see over here, the degree of the current remainder is 2. Divisor remainder, the degree of the divisor degree is also 2, so we have to continue with the division. I have to remove negative 9x squared. So here, negative, I need to have a negative here, negative 3. Okay, so 3 times 3x squared, I have negative 9x squared. So negative minus negative become negative 9 plus 9, so gone. Negative 3 times 5x, I have negative 15x. Negative 3 times negative 2, I have positive 6. So with all this, I have 19x plus 3. So to write them proper, okay, I will have 6x cubed plus x squared plus 9 over 3x squared plus 5x minus 2. So I have 2x minus 3 plus 19x minus 3 over 3x squared plus 5x minus 2. Then student will be wondering, hey, how come it's so weird? Whereby in front it told us dividends equals to divisor times quotient plus remainder. But how come here is a bit weird? Let me show you why this is the answer then. Okay, for this case, dividends equals to divisor times quotient plus remainder. This is the official way of writing. But this question don't start off with just the dividends. It start off with a fraction. So both side, I divide by 3x squared plus 5x minus 2. This is the divisor. Okay, so for this, I'll have 6x cubed plus x squared minus 9 over 3x squared plus 5x minus 2. So this will be the question. Then my right hand side, whole thing, I divide by 3x squared plus 5x minus 2, 2x minus 3 plus 19x plus 3. So with this, divide by 3x squared plus 5x minus 2. Then over here, my right hand side, I'll have 3x squared plus 5x minus 2, 2x minus 3 over 3x squared plus 5x minus 2, and I have 19x plus, yes, minus here. So minus, sorry, plus, my bad, here's plus, okay, plus over 3x squared plus 5x minus 2. So if this cancel, you can see my answer is the same. Okay, so please be mindful. Got it? Okay, that's why this is the proper way of presenting. Okay, this last one I will let you all do, but key thing, oh no, never mind, this one I will go through. Why? Because it's a bit different. Okay, this will be the questions to bring you all to remainder theorem, which I'll not be introducing today, but I will still go through this question. So 11, part 1. So they say this polynomial equals to x minus 2 times x plus 1 times q is a quotient. Okay, this is a quotient. Which, what is it? We do not know. Then plus ax plus b. This is the remainder. Then from here, these two, x minus 2 times x plus 1, this is the divisor. So which means that over here, we are asked to state the degree of the quotient. So the degree of the quotient, okay, will be, if we take quotient times divisor, we'll get the degree of the polynomial, which is the dividends. So the divisor degree is 2. Our quotient degree is 1. So our dividends degree is 3. It's 3, sorry, not 1, 3. So our degree of quotient will be just 1. Degree of quotient will be just 1. Then here, student, we have an issue. We are asked to find a and b, which is our concern. Question didn't ask us to find x. Question didn't ask us to find q. So because q is not needed, so our job is to remove off q so that we have less unknown to bother about, because if there are more unknown, more difficult. So same thing. Then going back to our method 1 in our solving multiple unknowns in polynomial, we always say that we search for any bracket, inside the bracket, any linear expression. So you can see here we have 2, x minus 2 and x plus 1. So we have 2 chances to multiply it. So when we sub in. So when we sub in, our q will be gone. So let's take a look. So 2, let x equals to -1. So with this, okay, my here will be -1 plus 1 becomes 0. So my q is gone. So good. So 4 bracket -1 cube minus 6 times -1 square plus 1. So I have a bracket -1 plus b. So I have -4 minus 6 plus 1 equals to b minus a. -9 equals to b minus a. This is my equation 1. There are 2 unknowns, so we need to create 2 equations. So the other equation is what? We have one more linear expression we have not used yet. So sub x equals to 2. Because here, 2 minus 2 becomes 0. So q also will be gone. So let's x equals to be 2. So I have 4 bracket 2 cube minus 6 2 square plus 1 equals to 2a plus b. So here I have 32 minus 24 plus 1 equals to 2a plus b. So I have a 9 equals to 2a plus b. This is my equation 2. So you can see this equation 1 and 2 both are linear equation. So which means if it's linear, we can use substitution, but it's very rare to perform simultaneous, to get 2 linear equations to perform simultaneous in AMF, because most of the simultaneous in AMF is substitution. So no problem. So I'll use elimination since it's linear the two equations are linear. So I have equation 2, 9 minus negative 9 equals to 2a plus b minus b minus a. So I have 18 equals to 3a. So my a equals to 6. Then I sub a equals to 6 into equation 1, which is negative 9 equals to b minus 6. So b equals to negative 9 plus 6. B equals to negative 3. So that is how we solve multiple unknowns in a polynomial. Thank you.